Hello everyone, and welcome to this Heat Roadmap Europe webinar. It's the seventh webinar this spring. My name is Rasmus Lund, and I'm part of the Heat Roadmap Europe team at Aalborg University. I'm here with my colleague John Papatinakis, also at Aalborg University, who is assisting me here, and we have Ulrich Reiter from TEP Energy online with us also, and Maarten De Groote from BPIE. And they will be introduced later. As I said, this is the seventh webinar in the series here. The first webinars can be found online on the Heat Roadmap Europe website, and this webinar will also be recorded and be available online after the webinar. The program for this webinar is that I will first be giving a brief introduction to the Heat Roadmap Europe project for those of you who might not have be familiar with it already. And after that, the main contribution for this webinar is Ulrich Reiter from TEP Energy, who will be introducing energy saving potential in buildings and the importance of low temperature heat demands. So Ulrich will be giving this talk, and he will be introducing himself and his presentation a bit more when he starts. After this contribution, we'll be having Maarten De Groote from BPIE, the Building Performance Institute Europe, giving his reflections and comments on the main talk of Ulrich, and then after that we will open for questions from all of you who are participating in this webinar. So welcome once again, and I hope you will enjoy it. So I'll just start out by saying giving a few slides on Heat Roadmap Europe and what it's all about. And in this slide here, you can see the pie chart is one of the important points here, and it shows that 50% of the total heat or energy demand in Europe is actually for heating and cooling. So when we want to decarbonize the energy supply in Europe, we really need to take a look at the heating and cooling to see how we can transition the energy supply to take this into account. Another important point is that when we look at the map, we can see that actually it's not only in the Nordic countries we have heating and cooling demands. It's spread across Europe, and also the heating demands is actually not only in the northern European countries but across Europe. So those are some of the important points. So these numbers here are of course for 2015, but what do we do when we want to transform this energy supply towards 2050? That is the big question. What role will the heating and cooling play in this? That is really what Heat Roadmap Europe is trying to answer. This work has been started and initiated already in a few previous projects. So this project is the fourth in a series of projects named Heat Roadmap Europe, and these have ranged from looking at the role of district heating in Europe, going to looking at the role of heat savings and the role between savings and supply, identifying this balance. And then in the third study, there was a more close look at the country-specific data, and looking at 4 different member states and making strategies for these, and Now, in the fourth study that we are working on right now, we are upscaling everything, you can say, both the amount of data and the detail in the data, and also the number of countries. So now we are going to 14 countries that cover. It's a really much more comprehensive study, but we expect that the conclusions here will support what we have found in the previous studies. So just a little overview. Here we have a lot of partners in this project, of where the 14 are research partners, actual beneficiaries in the project, and then we have 10 advisory board members. And this consortium is a really strong consortium, and it has a lot of different relevant competencies within this field. So it ranges from experts in buildings and industry and cooling, district heating, other local technology, different technologies relevant in this aspect. And we also have some local governments and the organization for local government. So we have covered a lot of different areas here for these areas. And yes. Going to look at some of the written purposes or the aims of this project is to create scientific evidence, because that's really some of the things that has been missing. Scientific evidence, of course, for the long-term energy transition, and how local, national, and EU level they play together here. So the purpose is also to create scientific evidence that is different levels to support the transition to a low carbon energy system. There are some illustrations here, some figures that show the transition in energy systems that we expect, and it's in line with the smart energy systems approach. I won't go into details here, but you can read more about it following the link in the slide here. Okay, so what are these heat roadmaps actually? Essentially, they are strategies, country-specific strategies of how to transition the energy systems in the different countries towards 2050. And this takes a close look at the heating and cooling sectors, both in terms of what actually constitutes the heating and cooling, and also where it's located. And this, together with a broader energy systems perspective. So how does the heating and cooling sector play together with the rest of the energy supply? Because the heating and cooling can, of course, not stand alone, as the rest of it cannot stand alone. So we need this integrated approach. And finally, we look at both how to decarbonize, but also how to do it in a socio-economic feasible way, because it's really important that we can do this in a feasible way. On the slide here, we have 4 pictures that indicate 4 different tools that we're using in this project. And going to the next slide. This illustrates. This is the second last slide I have, and this illustrates you can say the core method that we are using, or gives an overview of it at least. And we have basically developed some baseline scenarios that goes from 2015 and to 2050, showing what will happen in a business as usual scenario, you can say. And then adding on this, we have in this project developed a lot of data that describes different alternative potentials, including, of course, heat savings. That is one of the important topics of today's presentation. That is the forecast tool here on the left-hand side. That's the forecast tool is really contributing to describing what is the heating and cooling demands actually, and what does it consist of, and most importantly here, how can it be reduced and at what cost? The PETA tool here is a geographical tool that describes where the heat demands and heat sources are located, and has a lot to do with identifying the potential for developing district heating. And then we have the JRC EU Times model and the energy plan, which are both energy systems tools, but where Times is more looking at the transition of energy systems over time, and energy plan is more looking at the detailed dynamics from hour to hour across 1 year. And all these things are combined, and we then try to identify the best possible scenarios here, and based on that we develop some heat roadmap scenarios. Good. Now I have a slide here with recommendations, even though we haven't really finished the project, but these recommendations here are based on the three pre-studies that I showed you on the one of the previous slides, and of course detailing and elaborating on these recommendations here, but we expect to find something similar here. So what is important here, the slide here now, it's divided into 3 groups, and we find that everywhere heat savings are really important to save energy, and also because heat savings often is a really good socioeconomically, because there is just a big unused potential of reducing heat demand. But we have also found that there is a balance between savings and supply. So just reducing the heat demands to 0, like in passive houses or even plus energy buildings, that is not necessarily a good solution, because that additional savings might be more costly than it would be to provide the heat somehow. In urban areas, we find that district heating will play an important role, because this gives an opportunity to utilize excess heat from power production or industry or other activities in the society that provides heat, and this is hard to use without district heating systems. And at the same time, it is enabling much more renewable energy also in the heat supply. But it needs a high density of heat demand, so it limits to around roughly half of the heat demand. But this is something we will elaborate on in the current project also. Lastly, in the rural areas, we have found that electric heat pumps is one of the best options for supplying the heat that cannot be covered in any way else through either savings or district heating. There might be some biomass boilers also, but electric heat pumps has the benefit that it can use different sources through the electric energy system, depending on what we have of resources, for example, wind, solar, and so on. So this was my introduction to the Heat Roadmap Europe project, and I'll just, before giving the word to Ulrich, I'll just remind everyone in the audience now to remember any questions you might have, both for what I said, but of course mainly for Ulrich's presentation now, because there will be time for it in the end of the webinar. To take the word and give us your presentation.
Okay, thank you, Rasmus, and welcome everybody to my presentation today on the broad title, Energy Savings in Buildings, which I have to confine a bit, will mainly focus on the residential sector. The slides I'm going to present now, we're looking at energy demand reductions based on refurbishment measures in buildings. So the main goal of our work package and the results I'm going to present here was to calculate actual cost potential curves for reducing heating and cooling demand. That was work package 4. And as I mentioned before, this work is based on results from the forecast model, which were prepared in work package 3, where we have been calculating in the baseline the energy demand for the 14 European countries with the highest heating and cooling demand. Our input or our output will then be used as an input in the next model to do this evaluation between heat savings on the demand side or efficiency improvements and renewable energy on the supply side, as introduced before. Just some words on our team. I'm working for TEP Energy. We're a Swiss-based consultancy with a strong research background, mainly using forecast and our building stock model for estimating future energy demand from buildings. And these models have been developed in the last 10 years, and I'm working for TEP since 3 years. Before that, I've been working in a utility, in a Swiss-based utility, so also looking at the other side, on the generation side, and now trying to match these know-how. In this work package, we have been working closely together with the University of Utrecht and the Fraunhofer ISI, which have been looking at heat saving potentials in the industry sector. And on the cooling side, we had support from the Armin team in France. Residential and tertiary sector was developed from Fraunhofer ISI as well as TEP. And as mentioned before, I will introduce now the results for the residential sector. This is the short overview of the setup of the presentation. I will shortly introduce a forecast model, the way it works, the way it is designed with the 3 different subsectors. Then some additional words on the current status of energy demand, and from there developing energy demand drivers, giving an outlook on the results from the baseline on work package 3. The main part of the presentation is then on the energy savings in buildings, where I'm introducing the refurbishment measures which we have been considering, and from there deriving the cost of these additional refurbishments in case they were applied. On the one hand side, the additional savings, and on the other hand side, the additional costs. And the presentation will be then closed with a summary and some first conclusions. Here, this is a sketch of the setup of the forecast model, which is mainly based on 3 submodels looking at industry, the industry sector, the tertiary sector, and the residential buildings. These models, they're receiving input from 2 superior models, is forecast macro and the pricing, because we need these additional inputs which are going beyond the subsectoral aspects of each model. Are these either assumptions on GDP or energy prices, as well as population, employment, developments, as well as policies regarding the different energy efficiency aspects or decarbonization. As a result, from the model, we usually calculate consumption values. These can be either final energy demand or delivered energy, which is like in simple words, what is going into a heating system and what's coming out of the heating system within buildings. In this case, the results are looking at the delivered energy demand. Then we have potentials out of the models for different technologies, for refurbishment measures. We get results on indicators as well as greenhouse gas emissions. Looking at the current status of delivered energy demand, before it was already introduced, heating and cooling is very important, with approximately 50% of EU 28 final energy demand in 2015. This picture is very similar also on the delivered energy demand, where we have approximately 2,000 terawatt hours for these 14 countries in the residential sector. And if you are interested in more details, I refer to the webinar on the HRE seminar base from the 17th of May. So 2 weeks ago, these results were already introduced. Just to get the picture a bit more in detail, the composition of energy carriers is very diverse across countries, but in general terms, gas is the most dominant fuel in EU 28 for heating. Overall, fossil fuels account for more than 65%, and therefore, as introduced, the need for decarbonization of the heating and cooling energy sector, energy demand. Some words on the residential sector. Space heating is very important from the multifamily houses, as it is twice as big as the heating demand from single family houses in EU 28 average, but that again really depends on the country setup, on the country building stock, which we have included in the models. But this is just an overview. Renewable energies for heating as a main contributor currently is only biomass in substantial terms. Of course, we also have included solar thermal energy, geothermal energy, and heat pumps, but compared to biomass as a renewable energy, these are still marginal nearly in all countries. So therefore, if we look at technologies, this is of high relevance when decarbonizing the demand sector. As a last point, as the project is always on heating and cooling, in the residential sector, the cooling demand is covering approximately 2% of total final energy demand, which is currently relatively low, but the forecast is seeing a strong growth in the future, and therefore it's gaining relevance. And we will see also at the end of the presentation in the remarks that there is some need for improving also the models in this respect, that we combine even further heating and cooling demand. From the current status, of course, one is interested in the development into the future. How does energy demand look like in the future? Therefore, we have these energy drivers, energy demand drivers in the model incorporated. Some I've mentioned before. Population growth, of course, is one of the most relevant drivers, but from there derived the individual space need is of high relevance, because it's then driving the growth of energy areas, energy demand areas, therefore defining future development of demand. Building codes and construction practice is as well included. Building codes coming from the EPBD as well as country-specific regulations. What is the current building standard? What are for new buildings, but also partly for refurbishments. This needs to be included if we look into the development of the future building stock to derive to the demand reduction figures. Together with these building codes, the retrofit activities and the retrofit levels are also defining future demand. Currently, we see in average, let's say, retrofit ratios of between 0.5% and 1% of the total building stock, which is not sufficient to derive the targets, the EU targets until 2050. And that's also one part in the EPBD to increase this refurbishment rate. But currently we have in the model the existing rates from 0.5 to 1%, which are untouched. Some future demand drivers are indoor and outdoor temperatures, depending on the countries and the comfort levels for indoor temperatures, for example, in winter. Also the difference between the building code, what is like the setup for the indoor temperature, and then the actual user, which is maybe needing higher temperatures. We're getting this user, so-called user gap, which we also need to consider for estimating future demand. Just some graphs on the figures, also between the different countries, the development is varying. This is the living area per dwelling per household in square meters, where we can see the average living area is for most of the countries expected to increase in the future, but we also see some other countries like Poland, where the expectancy from the current status is that it's rather decreasing than increasing. But this is a very important demand driver. Then this graph is showing the building standards in the bars. One is seeing the current average U value of the 4 different building elements, which we are considering in the model. So if the building is defined, we define the envelope of the building by looking at the walls, the windows, roof, and the basement. And for each building element, there are from the current average standard of the existing building stock, which are depicted in the bars, and one can see as dots the minimum standards which are currently implemented in the building codes of each country, and therefore we see a large potential for efficiency improvement when the whole building stock is refurbished according to the new minimum standards. The bars would of course decrease then, and the U values would decrease to these minimum standards. So this is showing already in an overview the huge potential for future demand reductions. Based on these assumptions and the overall model setup, this is the overview from the baseline results, how we see the energy demand development, looking at the residential sector in the middle, the 3 columns in the middle, very important, the demand reduction for space heating with the green color, and as introduced before, in the residential sector as well as the tertiary sector, strong increase in space cooling demand. So this is the baseline results, which is defining the underlying figures on demand, as well as the potentials for refurbishment practice, which I will come to in the next slides. As said, from the baseline, energy savings in buildings can be achieved by refurbishment measures, and these are also depending, or the energy demand is depending also on the compliance rate, how good the efficiency improvement is achieved compared to the guidelines and codes, the building codes, and what is the deviation. Refurbishment measures on the building envelope is including the facade, like insulation of the facade with different thicknesses of the insulation material. What we have been considering, the same applies for the roof and the basement, what can be insulated, and the windows, which can receive an improvement by installing either double glazing, triple glazing, better efficient, higher efficient windows, which then are coming with a cost. In this model setup, we do not consider efficiency improvements of energy appliances, so improving the energy system, the heating system, is not considered in this current setup, because we are only looking at delivered energy, which is then the demand behind the heating system as introduced before. These refurbishment measures are organized in refurbishment packages. So when applying refurbishing one building, the model is deciding between different packages, saying it's only improving the window maybe, or it's doing a full refurbishment as the maximum possible in the baseline, considering all building elements, getting an energy efficiency improvement. And this slide is also important to consider, because it's again the baseline for the 3 time steps we have been looking at. The red bar is the current status, buildings from the 3 different building age classes, so buildings built before 1960, between 1960 and 1961 and 1990, and buildings built past 1991. In 2015, current status, and then in the model, in the baseline, the model decides for the specific refurbishment packages, which are mentioned at the right side, saying, oops, sorry. Refurbishment package 1 is the windows only. It's like the windows are exchanged, having a better energy and a better U value. Then we have the package 2, where windows and walls are refurbished to a low degree, let's call it. We have package 3, where besides windows and walls, also the roofs are improved. They get a refurbishment, better insulation, and package 4, which is then like a full refurbishment of the whole building envelope. And for the different time steps, 2030 and 2050, different shares of buildings are then refurbished. And from these refurbishment packages and the shares of refurbishment packages in the baseline, we then calculate the potential additional savings from additional measures, which I will introduce in the following. Just to sum up what was mentioned before on the energy efficiency gap, some reasons why we don't achieve the full potential from demand reductions can be partially because of inaccurate planning, that especially connection points are not well designed. There are reasons from wrongly applied minimum standards. Calculations are done in the wrong way, different or wrong codes are followed to actually calculate the setup of the refurbishment measures. Very important as well is a poor implementation or realization of refurbishment projects, heat bridges which are discovered during build-up construction. One can see raw material specifications that they are not fulfilling the expectations from the planned measures, or there are also deficient connections between building parts, etc., just to name a few. The last point, completely different from the build-up of buildings, is then the user behavior, which might deviate from the assumptions underlying assumptions in the building codes. And therefore, we have a deviation from the effective energy demand from the calculated energy demand from building codes and standards. That just at the side. Now, coming from the baseline calculations and the refurbishment packages, which I've been showing before, to the cost and performance of additional refurbishments. As said, we are interested in additional savings on top of the baseline, and we have therefore designed, outside of the model setup, additional refurbishment measures which can be applied to get some further energy savings. This has been done for the different building categories, single and multi-family houses, for the different age classes, and of course for the different building elements. So here, this is an overview of the different renovation refurbishment packages. Here again, the baseline with the current status. This is in addition. Of course, the current status can also include non-energetic refurbishments like wall paintings, which is important to see in case there is scaffolding included when painting the walls. Then by adding insulation, this cost of scaffolding can be shared, reducing the overall cost for the refurbishment measures, which is then energetic or has an energetic impact. And as we have been looking at the cost difference, this part is also of relevance, the share of buildings which have been only painted but not further refurbished. On top of the baseline, we have 3 options for additional measures in the full refurbishment, like migrating from a package number 5 to 6, 7, or 8. It's just giving the ID number. It is not so relevant. It's just for the completeness of the picture, by saying we are following the argumentation that someone which is already, or a building which is refurbished with a certain standards, it is more cost effective to increase the refurbishment depth by an additional 1 or 2 steps, maybe even to the passive house standard, as here in package 8. It's like saying, okay, the full refurbishment is planned, is introduced in the baseline, then the likelihood that one can be, or a building can be upgraded to a passive house is higher, as if we would say that a building where only the windows are exchanged or improved, a full refurbishment will be implemented on top of the baseline. Therefore, we have been selecting specific pathways how the baseline decision on the refurbishment package can be improved with a different migration pathway. So that's like a selective improvement. Here's the migration pathways are shown. As mentioned before, it's unlikely that one is moving from a simple renovation measure to a complete refurbishment package. Therefore, we have been selecting specific pathways, putting the underlying assumption that it is likely to increase the refurbishment depth by a few steps, but not by a whole set of different measures. Either because they are not needed, like building elements are not at the end of their lifetime. If one is replacing a window, the window lifetime is expected to have 20 to 25 years, and the walls are still in a good condition, then it is rather unlikely to do a whole refurbishment of the whole facade. One has to keep this in mind, and then we get here the first results from the additional energy savings and the movement of the refurbishment packages. Always in the left is shown the baseline as seen or as explained before, with the non-energetic renovations and the baseline packages. From there, we have been calculating extra savings, 5 to 25% for single-family houses. It's depicted in this case in Germany for the year 2050. So we have been calculating for all 14 countries these refurbishment packages, and one can see that, of course, the higher the additional savings, the more deep renovations are necessary to achieve these saving potentials. But also the building age is of high relevance. One can see here newer buildings, of course, they start from a different point in time. They are having or fulfilling already higher standards, and therefore, if someone is refurbishing, the new building codes are applying, and one can achieve with the partial renovations the expected savings. Here for the background, again, the way, the sketch, how we calculate the additional cost of specific measures. On the x-axis is shown the additional thickness of insulation. If one building has already been refurbished in the baseline, that will be point A here, and we calculate the additional thickness to achieve a higher standard up to level B, and then depending on the reference point, one can calculate as a difference this cost, saying that if the building has already an existing refurbishment, the additional cost here is defined by the additional material cost mainly, rather than material cost plus additional labor cost, which is also included. We have these two cost aspects in the model separately, that if one is doing only a simple overhaul, like painting the facade, like insulating the building, is not only costing the material, but also additional labor cost. And as the maximum, if nothing has been done, no scaffolding, for example, then the full cost would apply. So this is just summarizing what I've been showing in the graph before. Like we only consider the additional material cost, we have labor cost, and we have these cost factors derived from one publication and adjusted these for the 14 countries for the different material and labor cost indices per country. And as a result, we receive these cost curves. Now I see in the view, it's not showing the values, but is saying we start here in the baseline with the delivered energy demand of approximately 340 terawatt hours for Germany in 2050, and then we reduce the demand by 5% steps So -5%, -10%, -15%, -20%, -25%. And we see the increasing cost of these measures based on the different refurbishment packages which are needed, which are of course more costly if more savings are necessary. And this can be seen here, where we show the specific cost per saving. So we have simple measures like insulating roof or basement, which are coming along with a very low cost, but the overall energy reduction or the demand saving is limited, especially also here in this case, where it is the basement and then the roof P15, P14. Measures which have a higher energy demand reduction is the switch to the full refurbishment of the buildings which have been undergoing those measures, but of course they're coming along at a higher cost. And these different cost steps are then underlying for calculating the overall cost curves of the different countries and as well the different building types. Coming to the summary of the presentation, we have been calculating up to 25% additional energy savings in the buildings until 2050, excuse me, compared to the baseline. And this is reflecting differences in building status, so refurbishment versus non-refurbished buildings from the baseline in the different building codes, again, standards of new buildings versus refurbished buildings, and as well the building structure, single and multi-family houses, and also for the services sector, where the results are not currently presented here, but we're also part of the overall model calculations in work package 4. And these savings then come along with additional costs of estimated 700 billion euro until 2050, adding to the 1,500 billion euro, which are also included in the baseline cost to get these cost reductions, these demand reductions from the baseline. This as a comparison. The conclusions we draw from the calculations is that we see or suggest that the extra savings for the residential and tertiary sector should be first achieved by implementing more ambitious renovation measures, then implemented in the baseline or coming along with the building codes. And these should be applied for buildings which are undergoing a renovation anyway, because many of the work is already done anyway. So a building which is refurbished, it is more likely to achieve more energy savings by increasing, for example, the thickness of an insulation, then, and that's the second point, achieving the savings by increasing the refurbishment rate, which is considered in the baseline scenarios. Because we consider the package migration from doing nothing to doing something, this hurdle, this barrier, as higher as the barrier from increasing the renovation depth. But overall, both strategies are needed to then tap the additional efficiency potential. And of course, now we're interested and curious to see the results of work package 5, where we have this combination between the savings on the demand side and energy efficiency improvements and changes to renewable energies on the supply side. As a further remark, shortly introduced as well, space cooling is expected to increase drastically due to an increased cool floor area in the future, not only in the services sector, but also in the residential sector. And we have partially contradicting effects when calculating energy demand from buildings, name it glass values or airtightness of the envelope. On the one hand, by changing the glass factor, we might have higher solar gains in summer, higher solar gains in winter, reducing heating demand. But on the other hand, this would increase the cooling demand in summer, and therefore we need to find the integrated way of doing this heating and cooling demand planning of refurbishment measures in the future, especially when new building projects are coming. This planning, this combined integrated planning is of high relevance. That one is not only focusing on one aspect and then increasing the demand for the other demand. This, of course, is also depending very much on the country. Southern and northern countries, they have to look at the differences in the demand driver, but anyway, the integral planning is of very high relevance in this aspect. Therefore, I'm at the end of my presentation. I thank you very much for your attention. And if you have further questions, please contact me or have a look at our webpage of the project, where you find additional information and reports in case of interest. Thank you very much.
Thank you very much, Ulrich, for your very interesting presentation. Yes, so now I would like to invite Maarten to give your reflections on this presentation and your comments. So welcome, Maarten.
Good afternoon, and thank you, and thank you, Ulrich, for the presentation. A very first quick remark. You see, if you mentioned 25% savings additional to regarding the baseline, I think, and it's maybe an issue that all modelers have, or every model exercise has, is how optimistic is a baseline. And I think on European scale, we have a lot of work to do on implementation and compliance of regulation and objectives of policy. So I think in this perspective, as a gut feeling, I would say that the baseline is rather optimistic than maybe the realistic one, but that's a choice of the modeler. But then from BPIE perspective, we are a Brussels-based think tank, and we try to bridge between research and policy making. When policy making, we mentioned we cover both European and national and even local level of policy making. So my question is, how can we use these modeling results as an instrument to inspire policy and private sector developments for really having a better building performance across Europe? And a recent study that we have been doing is unfortunately showed that around 97% of the European building stock is not future-proof. So we did this based on available databases of energy performance certifications, and I think this 97%, that's a very important number, as we see from the European Commission quite often the number of 75% of buildings in Europe not being energy efficient, while we consider it's almost all buildings are not energy efficient. And if we make then the bridge between this modeling exercise on the heating demand, I think we cannot go around the current energy performance of building directive, which is being revised, which actually the revision finalized. And in there, the main result of the changes is that actually member states are required to focus more on the energy renovation of their building stock to transform it into a highly energy efficient and decarbonized stock by 2050. I think in his wording of a highly energy efficient and decarbonized stock by 2050, I think that says where we need to go to, and we need this modeling from both demand and supply side to merge into one. And I think these changes are timely, as the long-term climate and energy goals of the EU cannot be achieved without addressing energy waste in our buildings. So I think there is overall across Europe and actually in most countries covered by the HRE project, there's a sense of urgency missing. And Ulrich, you mentioned in your presentation energy demand drivers such as retrofit activities and building codes and construction practice. And I think it drastically needs enforcement. It's need to change, need to transform, and you need definitely compliance. And from that perspective, we definitely need renovation strategies with real implementation. And too often, many member states have a renovation strategy which is just a paper exercise, but we really need the real implementation. And then I would like to make the link to the renovation packages that were presented. I think what was clear from the exercise and the calculation is that if you implement renovation measures, that you absolutely have to avoid lock-in effect, which means that if you renovate or if you change your roof, that you have like already enough sufficiently insulation added. And just a practical example, I'm renovating myself, so I'm having the fun of having construction site at my house, and I had my steep roof has around 35 centimeters of insulation, and in the flat roof I had 16 centimeters of polyurethane insulation. And my dad was visiting me, and he is also renovating, and he told me, "You're putting 16 centimeters. Why is that?" And I said, "Yeah, but how much are you putting?" He said, 8. And I said, "Oh, how come you only put 8?" He said, "Yeah, I don't know how much to put." So I think if we set out renovation measures like insulation in roofings or walls or glazing, they have to be done from a future perspective, and that's quite often missing. So not only the building owners, but very much also the building sector are not aware of what energy level the future buildings need to have. So if you say, like, for this glazing, you need better to have a U value of 0.8 rather than 1.3, it's more easy and you guide better the building owner. So maybe I want to conclude. I have quite a lot more things to tell, but I think I will conclude with the last point on comparing supply and demand side. Is that BPIE, we analyzed both EU and non-EU funding streams available in Central, Eastern, and Southeastern Europe. It's a report we have available on our website, and we analyzed all these available fundings from Europe that could be used to improve energy efficiency of the building stock. So basically, or mostly, covering the demand side, and the sobering result was that only 3% of public funds that could be used to support energy efficiency investments are dedicated to upgrading buildings. And most funding for energy investments is directed to supply side infrastructure, such as gas pipelines and grids and so on. So I think that's a clear message that demand side projects such as building renovation are much more fragmented and often smaller in size than projects focusing on supply. And so therefore the effort required for preparation and administration of small projects can be taxing for public administrations. So that was a closing remark, and I hope that there come some questions to continue the debate. Thanks.
Yes, thank you, Maarten. Maybe just to react on your words, I think I fully agree on what you've been saying. Just on your first question, how these modeling results can be used to like link between research and the industry, I think there are 2 or 3 important aspects. One is the educational part, where all type of service companies or construction companies which are working on projects, that they are the employees are more educated to also consider energy questions, energy-related questions, demand-related questions, and advising their clients in the proper way. As you said before, what shall I choose? 8 centimeters, 16 centimeters. This advice needs to come, I think, from the building sector, the construction sector, and we need more educated, more skilled people to actually go into this direction. One thing we have been discussing here as well is then also standardization of measures. If you have a refurbishment, that many things should be prepared like in a fabric and then just delivered on site, and this would help reduce costs, which is also an important aspect to achieve these additional measures, also partially avoiding certain lock-in effects. And the last aspect regarding the funding streams which are available, I think that's also an important aspect, especially regarding the result. We've been showing that it is highly appreciated or highly needed, better said, to deepen the renovation measures. Here in Switzerland, we have a so-called building program where people can get subsidies if they renovate a building element, but they have to achieve higher standards than what might be economic feasible, in the sense that they only get a subsidy if they put 25 centimeters of insulation instead of maybe 16, which was calculated to be economic for them. So there are these building programs, but of course expelling that on other countries, implementing these funds in other countries might help to achieve these savings. Okay, are there any other questions?
Thank you, Ulrich. We have a few questions from the audience. One is, I think, mostly a comment, and that's from Thomas Knoll. He says that he finds that it's most important. One of the important factors is the role of the investors in this. And then there is two questions, and I think I'll just give them both of you to you now, and then you can reply on them. And the first question is from Kapil Narula, and it is a question to if you can please comment on the importance of the low temperature heat demands. Yes, and the other question is from Carolina Carmo, and that is based on your second last slide. Now I'm just reading here. If I read it correctly, it seems that that higher standards of refurbishment measures have a lower cost than the middle level. Can you please comment on that? So that is, have you understood the two questions?
Yes, I did.
Yep, good. So now I can just give your replies.
Okay, thank you very much for the questions. The role of the investors, that's correct, is very important. Of course, often this can be a barrier, especially if one is looking at all the buildings where like a generation change needs to take place in single but also multi-family houses, passing on buildings to the next generation. It's there, the role of the investor is very important. Also delaying investments because the decision is not taken, but that's completely different from investors which are doing this as pure investments. They have a different focus and they look at the investment in a different way. More on the cost side, so they rather do the minimum, and also there with potential funding streams, one might increase the refurbishment debt to a higher level. But it's correct, the role of the investor is of high relevance, but there are also studies looking into these aspects. The comment on the importance of the low temperature heat demand, I think one has to differentiate. Now I've been showing the results on the residential sector, which we are considering as low temperature heat compared to high temperature levels rather in the industry sector. But of course, one can also differentiate this low temperature heat in the residential buildings, looking at heat pumps, surface heating, which is even coming along with even lower temperatures between 30 to 40 degrees, rather on the higher end. But there, as introduced, the heat pumps are currently not implemented on large scales. That depends a bit on the countries. In Switzerland, the market shares are very much higher than in other countries. So far, it was always the discussion that heat pumps are more costly and not cost effective compared to other heating systems. This will change in the near future, and with the reduced energy demand from buildings with a higher energy standard, we expect that these very low temperatures between 30 and 40 degrees, they will have a high market growth. The second last slide, the higher standards have a lower cost. Yes, one has to be or look into more details of the migration packages, but it very much depends on the cost per kilowatt hour saved. It depends on the measures. So it's not always the case as it was stated in the question. It really depends on what is the additional material cost compared to the additional energy savings, and therefore this is depending on the measure implemented and the additional thickness, how these packages then are ranked in the model.
Yeah, if I may quick add something on that as well, on the role of the investors. The financing sector and the building sector, it's two completely separate worlds that speak in different languages. And I've been in the past, when I was working for the Flemish Energy Agency, been involved in negotiations with the banks to provide a more advantageous loan for NZEB buildings, for new buildings. And they were interested as well to do the same for renovation of buildings, but it was much more complicated. And it's really a very slow moving sector, the financing world, but I see some changes happening on European level. And I think crucial for them is that renovations are relatively small projects, so you really need to aggregate them to make a big funding or financing project for that. That's one. Second, investors, they require a certain quality assurance. So you need to have from a neutral body, mostly a government, a kind of an assurance that there is a quality delivered by the sector on the renovation. And thirdly, what is very relevant for the financing sector is actually the increased value that you create for the property after renovation. So for a bank, more often the increased value is more important than the energy savings during the lifetime. That's one. Second, I also want to react on the costs. I always find it dangerous or tricky to talk about costs and modeling, because then we have to define what are the actual and the real costs. Think about several multiple benefits of that can be brought in. Maybe again, the case of my own building. My wife, for example, she loves to walk around on naked feet, but our floor was not insulated. Actually, today they were insulating the floor, so in the future she will be able to walk with her naked feet in wintertime. What is the cost or what is the value of this? So I think we should take into account all the values that it brings. And if we talk about energy poverty, there's definitely health issues taking a role as well. So that was my last feedback. Thanks.
Thank you, Maarten. Ulrich, do you have any final remarks?
No, I think I think that's okay.
Okay. Thank you very much, both of you. I think then we will conclude this webinar as we are already a bit over time. But I just want to tell you that this webinar series will be continued in the autumn of 2018. So if you follow on the Heat Roadmap Europe homepage or on the sign up for the newsletter, then you'll be able to follow when the webinars are scheduled. So thank you for watching this webinar, and I hope you enjoyed it and learned something on it. Have a nice day. Bye.
Thank you. Bye.
Bye bye. Thank you.